Hi all, have a good day. I am K. Surya, working as Assistant Professor in the Department of ECE at SNS College of Technology. Today, in this lecture, let us see about star-delta conversion techniques. So in the star-delta conversion technique, it is used for simplification of the circuits so that we can easily solve the problems. Some resistor networks cannot be simplified using the usual series and parallel combinations. So in that cases, you can convert a star type of network into a delta and simplify it easily, or we can convert a delta into a star and simplify it easily. So the transformation helps us to replace the 3 resistors in the delta configuration by 3 resistors in the star configuration or vice versa. So this is a figure showing the star and delta connection. So the star connection is in the Y shape and it's also known as Y network, and the other one is in the triangular form and it is known as delta network. So the star network, the resistors are represented as R1, R2 and R3, and in delta networks it is represented as RA, RB and RC. So this is a 3 terminal arrangement which is commonly used in power systems. So delta connection has 3 nodes while Y has 4 nodes. So if you see in the diagram, you can see it. So the configurations can be redrawn like a square shape as shown in the figure, and this type is known as pi network and T network. So instead of star and delta, you can also write it as T and pi network. So this is the equation for transforming a delta network into a star network and star network into a delta network. So in the delta to star conversion, so in the star network it is represented as R1, R2 and R3. In the star network it will be R1, R2, R3, and in the delta network it will be RA, RB and RC. So in order to convert delta network into a star network, we can do it by using R1 is equal to RB RC divided by RA plus RB plus RC. So R1 is the equivalent resistance of RA, R2 is the equivalent resistance of RB, and R3 is the equivalent resistance of RC. So you can calculate it using these formulas. Similarly, in star to delta conversion, your RA represents your equivalent of R1. So you can calculate R1 as R1 R2 plus R2 R3 plus R3 R1 divided by R1. Similarly, RB is R1 R2 plus R2 R3 plus R3 R1 divided by R2, and RC is R1 R2 plus R2 R3 plus R3 R1 divided by R3. So using these formulas, we can convert a star to delta or delta to star network. So if RA equal to RB equal to RC is equal to R, all the resistances are the same, then R1 equal to R2 is equal to R3 is equal to R by 3. Similarly, if another case RA is equal to RB is equal to RC is equal to 3R. So consider you are having a delta network consisting of 3 resistors, and the value of all the 3 resistors is 3 ohms. So we want to convert it into a star network. So you can calculate it using R1 is equal to RB/RC divided by RA plus RB plus RC, where 3 into 3 divided by 3 plus 3 plus 3, which is equal to 1 ohms. Similarly, we can calculate R2 and R3. Since all the resistors are 3 ohm resistors, the value will be the same for R1, R2 and R3. So all the 3 resistors are 1 ohms. So 3 ohms resistor in a delta network is equivalent to 1 ohm resistor in a star network. So this is the conversion diagram. So delta network is converted into a star network with 1 ohm resistors. So next one we will take in the reverse manner. So in the same figure, we can convert a star network into a delta network in the reverse. using the formula. So RA is equal to R1 R2 plus R2 R3 plus R3 R1 divided by R1. So in the star network it is always 1 ohms. So when you substitute the value of 1, you will be getting 3 ohms. So similarly for RB and RC. So all the 3 resistors will be 3 ohms as we saw in the previous delta network diagram. So next consider this example. So here you want to find out the equivalent resistance, which is mentioned here in the figure as R equivalent. So in this figure you can redraw this network like a pi network also. So you consider ABC. So the ABC delta is replaced into a star network using the delta to star conversion formula, and the circuit will be changed like this. So from here you can calculate the R equivalent. So here if you see the 9 ohms and 2 ohms are in series. So 9 plus 2 is equal to 11 ohms. And if you see from that junction of 2 ohm resistor, your 4 and 8 ohms are in series, and 2 and 4 ohm are in series in the right side. So you can add them. So 8 plus 4 and 4 plus 2, and that resistance, both these resistances after adding up will be in parallel, and you can put parallel combination, and finally you can add all the 3 resistors, which will be equal to 15 ohms is the equivalent resistance. So next one is in this diagram you have to find the equivalent resistance between the 2 terminals mentioned here. So here also you can convert any one top or bottom delta connection into a star connection. So before that you can, in order to avoid confusion, you can redraw this like this. So both pi and delta networks are the same. So you are redrawing it and you are converting the bottom network into a star network. Okay. So you select one of the delta networks to convert to a star network, then we will be performing delta to star transformation. So this is how we will be transforming it. So compute the 3 new resistor values, and then you have to calculate the equivalent network. So this will be the equivalent diagram. So in the top figure you will be finding out the equivalent. So here the left side 2 resistors and right side 2 resistors will be in series. When you add up you will be getting 4.375 and 5 ohms, and these two will be in parallel, and finally you will be getting what, 4 ohms, right? So the parallel resistor value is 2.33 and plus 1.66, you will be getting it as 4 ohms, the equivalent resistance. So hope you understood star delta conversion. So let us take up some assessment questions. Which among the following is the correct expression for star delta conversion? Yes, the answer is third option. R1 is equal to RA plus RB plus RA into RB divided by RC. So here you can take LCM. So if you take LCM, you will be getting RA RC plus RB RC plus RA RB divided by RC. So this is the equation which we saw. Next one is delta connection is also known as mesh connection. Next one is RA is resistance at A, RB is resistance at B, RC is resistance at C in a star connection. After transforming to delta, what is the resistance between B and C? So this is star to delta conversion formula. So resistance between B and C is represented by what? R2. So the equation will be like this. RC plus RB plus RC into RB divided by RA. So here also you can take LCM and check. So you'll be getting RA RC plus RB RC, RA RC plus RA/RB plus RB/RC divided by RA. Thank you for watching this video.